Hello, 8th graders. In this week's algebra class, we are going to learn about numerical and algebraic expressions. Our objectives are to write and evaluate numerical expressions and to write and evaluate algebraic expressions. By the end of this lesson, we will be able to represent and evaluate mathematical expressions, including numerical and algebraic. We are going to start off discussing the vocabulary that we need to be familiarized with for these two topics. First, we have that numerical expressions are mathematical phrases that involve only numbers and mathematical operations. You can observe an example there. These has numbers and three mathematical operations. So this is a numerical expression. 3 times 2 cubed divided by 6 plus 30. An exponent is a number written above and to the right of a mathematical expression called a base. It indicates that the base is to be raised to a certain power. So here in this numerical expression, we have an example of an exponent. The exponent is the small number to the right of the base. Okay, and this is read 2 cubed or 2 to the third power. Next, we have the word base. This is a number that gets multiplied when using an exponent. So just like in the example above, all of these here is a power. The number 5 is the base, and this is the number that is going to multiply itself. And the exponent, or the number raised to the right, determines how many times the base is going to be used as a factor. So in this example, 5 squared means that this number 5 will be used as a factor 2 times. So we would say 5 times 5, that is equal to 25. To evaluate means to find the value of the expression when the variable is replaced by a given number. So in shorter words, to evaluate means to substitute. Whenever we are evaluating expressions, we are going to substitute the variable by the given number. An algebraic expression is a mathematical expression made up of variables and constants along with algebraic operations. So here, to the right, we have an algebraic expression. It's made up of variables. In this case, it's this letter x. Letter x is the most common letter used as a variable. It's also made up of constants. This number 3 is a constant, and algebraic operations. This example is only a subtraction here. That is what it's representing here, subtraction, and a multiplication right here, 5x. Next, we have the word variable, which is a letter standing in the unknown numerical value of an equation. So once again, going back to the example, this x here is the variable. It represents an unknown value. A term is a single mathematical expression. So these number 5 and these number 3 are the terms in these expressions. Next, we have variable. Okay, variable once again, and we already mentioned it is a letter used to represent a value. And finally, a constant. A constant is the term that does not contain a variable, like these number 3 that stands alone in the expression. The order of operations is something I'm sure you have worked with before and you're familiarized with. So we're going to quickly go over it. It's represented by the acronym PEMDAS. The letters, or these letters, stand for the operation and the order in which they have to be done. So the letter P in PEMDAS um, tells us to solve anything that is inside the parentheses first. Then the E in panda stands for exponent, meaning we need to, after solving anything inside parentheses, we are going to solve the exponents. Next, we have M and D, which stand for multiplication and division. Multiplication and division are going to be solved after exponents, and remember that these have to be solved from left to right. So whichever we find first, from left to right. Then we have addition and subtraction, and just like multiplication and division, we solve whichever is first from left to right. Below the chart, we have a couple of examples. The first one, 3 plus 7 times 6 divided by 3. So we check using PEMDAS. There are no parentheses. There are no exponents. And then we check for multiplication or division. Like I said, we solve whichever is first from left to right. So in this case, the multiplication is first. So we solve for 7, or we simplify 7 times 6, which is 42, and copy everything else. 3 plus 42 divided by 3. Once again, using the order of operations, our next operation would be the division. So we copy these numbers 3, we just bring it down and we divide. 42 by 3 equals 14. And once we're down to one operation, we add 3 plus 14 for a final sum of 17. In our second example, we have inside parentheses 6 times 4 divided by 3 minus 6 plus 2. According to the order of operations, the first thing we are going to simplify is whichever operation is inside the parentheses. So we solve for 6 times 4, which is 24, and we copy everything else. Divided by 3 minus 6 plus 2. Next, we solve the division exercise here. 24 divided by 3 equals 8. And we will copy everything else. Minus 6 plus 2. Next, we have a subtraction and addition. We are going to solve them from left to right. So we subtract first. 8 minus 6 is 2. Plus, we copy the rest of it, plus 2 for a final sum of 4. And our last example shows us an exponent. So here we have 2 squared times 9 divided by 3. First of all, we check for parentheses. There are none, so we solve the exponent. 2 squared is the same as 2 times 2, which is 4. So we have a 4 here. And we copy the rest, times 9 divided by 3. We have a multiplication and a division. We are going to solve from left to right. So we multiply 4 times 9, which is 36. And we copy the rest. 36 divided by 3 equals 12. This is how the order of operation is going to help us simplify these expressions. And what we are going to do during the rest of this week is to evaluate expressions. So to evaluate an algebraic expression, you first replace each variable with a given number. Then you use the order of operations to simplify. Keep in mind what I told you earlier. To evaluate an expression basically means that you are going to substitute the value for its given, the variable by its given value. So in this example down here, we are going to evaluate for y minus 16 for y equals 9. So the variable y has a given value, which is 9. So we are going to minus 15. Next, we apply the order of operations. And we have that 4 times 9 is 36, and we copy the rest of it. So 36 minus 15, finally, We subtract, and the difference between 36 and 15 is 21. To rewrite this expression, replacing the variable by its value. So that's evaluating it. So we substitute, right? Instead of writing 4y, we now know the value, so we are going to write 4 times 9. It's a multiplication, and we copy the rest of it. Okay guys, so now we're going to practice algebraic and numerical expressions. So as you heard before, a numerical expression involves only integers and mathematical operations, while an algebraic expression contains variables. So the first example is one of a numerical expression that we are going to simplify. So to do this, we use the order of operations. As a reminder, I'm going to write up here the order of operations or PEMDA. So we begin looking for any parentheses or another grouping symbol. These exercise does not have any. So um, next we have to look for exponents, and there is one exponent here. So this is the first thing we will simplify, and we are going to copy everything else. So that's going to be 20 minus 7 plus 8 squared is 64 minus 7 times 11. Remember that multiplication can be represented by the suspended dot or by a parenthesis. Next, according to the order of operations, it's either multiplication or division. So we have a multiplication here. That's what we're going to solve next. So we're going to copy 20 minus 7 plus 64 minus, and we will multiply 7 times 11, which is 77. So now we simplified for parentheses. There were non-exponents, multiplication or division. Now we have addition or subtraction, whichever we find first from left to right. So there is a subtraction right here. 20 minus 7 is 13. And we copy everything else, plus 64 minus 77. Once again, we have addition and subtraction going on. We're going to do the first one from left to right. Therefore, we are going to add 13 plus 64. So 4 and 7 is 77 minus, we copy the 77 we have here, and we are down to one operation. So we subtract. 77 minus 77 is 0. So here we have simplified our numerical expression. Now we will do one, also a numerical expression, but this one is going to involve grouping symbols. So we will have, let me just copy this one down, 4 plus 5 to the second power over 3 and 7 minus 4. Okay, so our grouping symbols are the parentheses, and this line that represents a division is also a grouping symbol. So let's start solving these numerical expressions. We will solve what's inside the parentheses first. So 4 plus 5 is 9. And let's not forget that is to keep the exponent, so 9 squared, the division line, and then we solve what's inside the parentheses here as well. So it's going to be 3. I open the parentheses, and 7 minus 4, which is going to be 3. We continue solving these. Now we have to work with the exponents up here. So 9 squared is 81, 9 times 9. And then down here, 3 times 3 is 9. Now we're down to one operation. The fraction line also represents division. So this is 81 divided by 9, which is 9. So this would be our final answer here. So we did examples for numerical expressions. Now we will do an example for an algebraic expression. Like we already know, algebraic expressions are those that involve operations, integers, and also variables. So here, when we evaluate an algebraic expression, this basically means that we are going to substitute the variables in these case A, B, and C for their given values. So first thing I'm going to do is substitute. So A equals 2, so this will be 2 squared. I open the parentheses. This represents a multiplication, so 3 times B equals 6 minus A equals 2 plus 5, I close my parentheses, divided by C equals 4. Once I've done all the substitutions, I can go ahead and solve or simplify my algebraic expression. So I'm going to start with, according to the order of operations, everything that is inside the parentheses. So I'm going to copy the exponent, 2 squared, and inside the parentheses, there are several operations, and I will still respect the order. So first, I'm going to solve this one here. 3 times 6, which is 18. And I will copy the rest. Minus 2 plus 5. I close my parentheses, divided by 4. I still have operations inside the parentheses, so I continue working out those. 18 minus 2 is 16 plus 5 divided by 4. There's one more operation inside this parenthesis, which I will solve next. 2 squared. 16 plus 5 is 21 divided by 4. Okay, now I'm done with one single number integer inside my parentheses. So now I will solve the exponent. 2 squared is the same as 2 times 2, which is 4, times 21 divided by 4. I have a multiplication here and a division. According to the order of operations, I will do my multiplication first. So 21 times 4. 1 times 4 is 4, and 2 times 4 is 8. So 84 divided by 4. Okay? And I'm down to the final operation. So 84 divided by 4. Here we have 4 divided by 4 would be 1. 8 divided by 4 would be 2. So my final answer here would be 25.